Okay, I'm Mrs. Schomer, and today we are going to look at pressure conversions. Let's first talk about pressure, right? When we look at this picture, remember the definition of how we increase pressure is hitting the sides of the objects, hitting the sides of the container. So you can see pressure increases every time how hard it hits and how often it hits on the inside of its container. The problem with pressure is that scientists could not agree on what units to use. So we have atmospheres, we have kilopascals, we have millimeters of mercury, we have, sorry, I'll present this, right? We have multiple different types of pressure units, kilopascals, millimeters of mercury, and pounds per square inch. And if you look over on the side here, we have a barometer. So this is just an example. If we're measuring in millimeters of mercury, you've got atmospheric pressure pushing down on the mercury, and then it's going up the glass tube. So then you're measuring in millimeters or in inches in this case, and you can see in parentheses, that would be the millimeters of mercury of that pressure. Okay, so you can see more atmospheric pressure pushing down causes more mercury to go up that tube. Okay, less pressure, less atmospheric pressure, less mercury, less millimeters of mercury would be going up that tube. So just an example of how a barometer is used to measure pressure. Now, pressure is always measured at sea level, right? So at sea level, so we have standard temperature and standard pressure, and I'll have you write that down in a couple slides here. But we're going to go through what our standard pressure and what our standard temperature is. It's always going to be taken at sea level, right? So these are all the standard pressures. It's 1 atmospheric pressure, and again, it's based on the air pressure at sea level, right? So like 0 degrees Celsius, right, about the freezing point of water at sea level, where there would be the most air pressure, right? Most air particles is where the standard pressures are taken. So 101.325 kilopascals. 760 millimeters of mercury. So these are all taken at sea level, 14.69 psi, pounds per square inch. And they're all, so we know that all those measurements are taken at the same place, all at sea level, where there would be the highest amount of pressure. Because standard pressure is all related to air pressure at sea level, then these are all just a way of saying the same thing. They're all equal to each other. It's kind of like saying 1 foot equals 12 inches. That means they're equal to each other. 1 hour is 20, 1 day is 24 hours. Those are equal to each other, right? You could set them out. It's the same thing because these are all taken at the same place. It's just a different unit of measurement. This is important because sometimes you're going to need to convert back and forth. So that's what we're going to practice today so that you can do your problems for the assignment. I want you to take a second and pause right here and write this down in your notebook so you have them for problems. You will always be given these on any quiz or test. You don't have to memorize it. You will get used to it after you practice them a while, but you can go ahead and pause and write these down in your notebook. These are all standard pressure and temperature. And again, we've got temperature in there because you already did temperature conversions, right? 273 Kelvin or 0 degrees Celsius is standard temperature. You may have a problem that comes up that says, you know, calculate this, and it's based on STP, which means you'd use standard temperature and you'd pick a standard pressure to plug into the problem to use. And again, it's all at sea level, right? At about 0 degrees Celsius, the point where water freezes right at sea level. All these pressures are taken at sea level. So we'll write them in your notebook. STP. Whenever you see STP, it means standard temperature and pressure. All right, so conversion refresher. I'm going to walk through. There's 4 problems on here. I'm going to walk through the first 2, and then I want you to go ahead and try the last 2. So here they are. We're going to walk through the first 2, and then I'll put the other 2 up so that you can practice them and see if you can get them right on your own. I'm going to go down here because I already have them up so that I can write. All right, so when we set these up, we're going to do dimensional analysis to set these up. And so you've got all your standard pressures up there. They're all equal to each other, so I can use them as a conversion factor. So we've got 43 PSI, pounds per square inch. I'm going to set it up, and you can set this up. It's the same way as this is multiplication, so you can write it as 43 PSI times, and then put your fraction in. It doesn't matter. It means the same thing if you use fractions. I'm just using a table to set it up, okay? So I can keep going. when I look at this, I'm trying to get to millimeters of mercury, so I always write out here what I'm trying to get to. Now, these are equal to each other, so I can set up a conversion factor. So it's converting, we've got pounds per square inch and millimeters of mercury. So I can write my conversion factor as 76 millimeters of mercury. You can write it two ways. Here, I'll make it simpler than that. Since they're equal to each other, right, I can put 14.69 psi right here, and I can put 760 millimeters of mercury right here. Okay, so here's one conversion factor, and here's another conversion factor. Now let's look and see what we need to plug in right here. Remember, for dimensional analysis, you need to be able to cancel units. So the only one that's going to be able to cancel units is this one with my PSI on the bottom. If I use this one, my units won't cancel, and I won't end up with millimeters of mercury on top, which is what I'm trying to get to. So I'm going to go ahead, and this one is not going to be the one that I use. I'm going to use this one. So I'm going to put 760 millimeters of mercury on top, and I'm going to put 14.69 psi on the bottom. PSI cancels, you're left with millimeters of mercury, and it's simple math at this point. So it's 43 times 760. You multiply everything across the top that you would have, multiply everything across the bottom, and then you divide because it's a fraction. So 43 times 760 divided by 14.69. And I end up with 2,224.64 millimeters of mercury. Okay, I'm just always going to round two places past the decimal just to keep it simple. Okay. Now, looking at the next one, you can pause this and see if you can figure it out on your own. And get the correct answer. I'm going to go ahead and set it up. 200 kilopascals, right? Set up my table, which means the same thing as fractions, and I'm trying to get to atmospheric pressure, okay? So again, here's my conversion factors, 101.325, because these are equal to each other, or 1.000 atm, atmospheric pressure. Now, if I look, kilopascals needs to end up on the bottom, right? Because I want to be left with atmosphere. I can't cancel units unless they're on the bottom. So it's not going to be this one. I'm going to have to use this guy as my conversion factor. So 101.325 kilopascals is on the bottom, and that's equal to 1 atmospheric pressure. They're equal to each other. This is standard. This has been measured. So I don't have 101.325 kilopascals. I have 200 kilopascals. So I want to figure out how many atmospheres that is. When we look at it, it should be greater than 1. If I have 200 and this is 101, right, I have almost double that. So you can start to think about what your number is going to look like too. Now, when I go ahead and calculate this, right, kilopascals cancels with kilopascals. 200 times 1, I divide it by 101.325, and I'm left with about 1.97 atmospheres. I just go two places past the decimal again. So it's almost 2 atmospheres, right? Because it looks about doubled. Okay, so that's how we set them up using dimensional analysis. You can go ahead and if you feel comfortable, go ahead and start doing your Go formative problems. Otherwise, actually try these problems, these two problems. Go ahead and try them, press pause, try them. And then if you get them right, just go ahead and do the problems in your assignment. Otherwise, if you get them wrong, then watch me. So number 3, I'll put the answer over here. The answer to number 3 is 1535.2 millimeters of mercury. And the answer to number 4 is going to be 99.73 kilopascals. Okay. So if you didn't get those right, I'm going to go ahead and set it up. I'm going to be 2.02 atmospheres to millimeters of mercury. Give myself some space, right? Atmospheres has to go down here because I need to be able to cancel. So if I look at my conversions at the top, 1 atmosphere is equal to 760 millimeters of mercury. Remember, these things are all equal to each other. So I can set them up as a conversion factor that's equal. So atmosphere cancels with atmosphere. I'm left with millimeters of mercury, which is what I was trying to get to. So now it's just about the math. If you look at it, it's 1 atmosphere equals 760, and I have 2 atmospheres, so that's almost double what standard pressure is. So 760, I probably should have about double that. So when we look at it, my final answer, when I take 2.02 times 760 divided by 1, I end up with 1,535.2 millimeters of mercury, right? Same answer that I wrote over here, okay? Now, looking at this one, I've got 748 millimeters of mercury, and I'm trying to get to kilopascals. So when I take a look at this, I have millimeters of mercury, needs to go on the bottom so I can cancel. And I'm trying to get to kilopascals, so that goes on top. So if I have 760 millimeters of mercury, and right from up here, my standard pressure is 101.325, right? I have almost standard pressure. I'm at 748, so it should be pretty close to about 101.325. So millimeters of mercury cancel, and I'm left with kilopascals, so 748 times 101.325 divided by 760, and you should get the same answer I have over here, 99.73 kilopascals. And that's how you do conversions. Go ahead and do your practice problems.